Today we're going to talk about one-to-one functions. This is part one of a two-part screencast. So a function f is one-to-one if different outputs always give different inputs. So here's an example of a one-to-one function. It's saying different outputs. Outputs are usually the y value, and the inputs are usually the x value. Okay? So let's look at an output like a y value of 3. Notice when y is equal to 3, the x value is 1. This is at the point 1, 3. All right? Let's look at another value. Let's say at the point y equals 4. At 4, notice that the x value is approximately 1.5. So let's call that 1.5. 1.5, 4. And if you notice, for every single point on this function, for every y value, there's only one x value. And that is something what we call the horizontal line test. Here's a y value. Notice how it intersects the graph in only one spot. So one x value, a y value, only one spot. A y value of -1 intersects the graph in only one spot. And that's true for every single point on this function. And if that is true, then it is considered a one-to-one function. The easy way to tell is if it passes the horizontal line test by drawing horizontal lines through the graph, and if there's every single horizontal line only intersects the graph in one spot, it is considered to be a one-to-one function. So the question might come up, what does a function that's not one-to-one look like? Well, here's an example. So notice in this case that if I pick a y value, let's say 3, and I draw my horizontal line, it will intersect the graph in two places. And if that happens only one time and no other times, it's still not one-to-one, because it must pass the horizontal line test every time. So obviously it fails it there, it fails it here. Notice right here, right at 0, it does pass it, but it fails it in every other point. At every other point, it fails horizontal line test, because for every output, for every y value, there are two x values. So this fails the horizontal line test. And therefore, it is not one-to-one. So just to review, a function f is one-to-one if different outputs or different y values always give different inputs or different x values. And the easy way of telling if a function passes the horizontal line test, then it is a one-to-one function. Okay, and now the moment you've all been waiting for. Yes, now it's your turn. So what we want you to do is determine if these functions are one-to-one. If they're not, please state why. Okay, so two functions. If you're having trouble, we'll go back and review the screencast, see how you can determine if functions are one-to-one, but please state why it's not one-to-one if it's not. I hope this was helpful. Good luck, and see you again next time.